You've found Dreamtime Science, a peaceful corner where we unravel the mysteries of our universe one whisper at a time. Let the gentle current of discovery carry you towards sleep. You know what's fascinating? I've been thinking about how tiny ants manage to create these enormous supercolonies stretching across miles without any single leader telling everyone what to do. There's something remarkable about how they work together so seamlessly, almost like a quiet, natural symphony, no conductor, just perfect harmony. I can't wait to share with you how these little architects pull off such an incredible feat, all while staying so wonderfully organized. A soft tap of the like button or a whispered subscription tells me these calming discoveries resonate with you. What aspect of science brings you the most wonder? Before we begin, create your sanctuary, nestle into your chosen spot, let your muscles soften, and allow your breath to find its natural rhythm. Beneath your feet, tucked between tangled roots and clods of dark, fragrant soil, the world of ants hums with a purpose older than cities and more intricate than clockwork. In the hush of evening, when the air is heavy and the garden seems to settle in anticipation of dusk, you might pause and peer closer, letting your gaze soften and drift across a patch of ground. There, among splintered twigs and fallen petals, you may detect a line, a shimmering procession of tiny forms, each one purposeful, each one seemingly aware of its place in a vast choreography. At first glance, ants are almost invisible, black or russet specks, darting and pausing, bearing loads many times their weight. Yet, if you watch long enough, a pattern emerges. Lines of ants flow along invisible highways, some returning heavy-laden, some leaving empty-mandibled, others pausing to touch antennae in brief, silent exchanges. The longer you look, the more the illusion of chaos falls away, and a strange, almost unsettling order reveals itself. You are witnessing the surface ripples of a hidden universe, a civilization constructed not of stone or steel, but of collective will and instinct, a society where the boundaries between self and collective blur and intertwine. It is easy, standing at the edge of this miniature empire, to dismiss the ant as a simple creature, a speck of life, an automaton of the dirt. But this is a dangerous underestimation. Ants are architects and engineers, strategists and farmers, raiders and caretakers. Some species cultivate fungus deep underground, their chambers humid and carefully tended. Others tend herds of aphids, milking them for honeydew as patiently as any dairy farmer. And most astonishingly, certain ants build societies so vast, so intricately connected, that biologists have come to call them supercolonies, entities that span continents, consisting of billions of individuals, yet operating as if a single distributed mind. The idea of a supercolony is both humbling and disquieting. Imagine a society not of millions or even billions of individuals working together, but of individuals so synchronized, so seamlessly integrated, that their very identities merge. There are no bosses, no central controllers, no queen in charge, as fairy tales might suggest. The queen lays eggs, yes, but she does not rule. Instead, order emerges from the sum of countless local interactions, each ant responding to chemical signals, tactile cues, and the subtlest of environmental changes. There is no master blueprint, only a living algorithm, a dance of feedback loops, trial and error, and collective memory encoded in scent and action. Consider for a moment the Argentine ant, Linepithema humila, a species that has spread across the globe with breathtaking speed. In its native South American range, it lives in modest colonies, but when introduced to new continents, free from many of its natural enemies, it accomplishes something extraordinary. Along the coasts of California, across swathes of Europe and Asia, Argentine ants have formed supercolonies that stretch for hundreds of kilometers. In these regions, millions upon millions of individuals cooperate without the fierce internecine wars that normally mark the boundaries between ant colonies. Workers from a nest in Barcelona will greet, not fight, workers from a nest in Marseille, as if they were kin. The supercolony recognizes itself not by a central command, but by a shared chemical signature, a common dialect of pheromones that binds all members into a unified whole. It is here, in the silent cities beneath the grass, that the boundary between nature and science fiction begins to blur. Human imagination has always been both fascinated and unsettled by the idea of collective intelligence, a mind distributed across many bodies, a will that arises from the sum of its parts. Our stories are haunted by the image of the hive, the relentless, coordinated swarm, the loss of individuality in the face of overwhelming unity. In the realm of science fiction, perhaps no vision is more iconic than the Borg collective from Star Trek, a race of cybernetic beings who have surrendered individuality for the perfection of the hive mind, each voice subsumed into the chorus of the many. The parallels between ant societies and the Borg are more than superficial. Both are decentralized, lacking a singular leader or dictator. Both rely on local rules, simple instructions followed at the level of the individual, yet yielding complex, adaptive behavior at the level of the whole. The Borg's chilling refrain, "Resistance is futile," echoes the inexorable advance of an ant colony overrunning a landscape, adapting and optimizing, always seeking, never stopping. In both cases, there is a sense of inevitability, an impression that the system as a whole possesses an intelligence greater than the sum of its parts. Yet the comparison also reveals a deeper, more subtle truth. In the world of ants, as in our myths of the collective, individuality is not erased, but transformed. The ant is not mindless. Each worker navigates, decides, remembers, and learns within the constraints of its biological programming. It knows the chemical scent of home, the taste of danger, the feel of the sun on its exoskeleton. But at every turn, its actions are shaped by the presence of others, by the trails of pheromones left by sisters, by the vibrations of the nest, by the ever-changing needs of the brood. The ant's sense of self is inseparable from the colony, a selfhood that is porous and contingent, defined by 1,000 invisible threads connecting it to the wider whole. This is the genius of the supercolony, not central control but distributed intelligence. Each ant acts on local information, yet the colony as a whole achieves feats that would seem to require planning and foresight. Ants will bridge gaps with their bodies, forming living chains over streams. They will divide labor with astonishing flexibility, shifting from foraging to nursing to defense as the needs of the colony shift. When danger threatens, they mount coordinated defenses, sacrificing themselves without hesitation for the survival of the whole. No ant understands the plan, yet the plan emerges. How does this miracle of coordination arise? The answer lies in the language of chemicals. Pheromones, volatile compounds exuded from glands on the ant's body, are the words and sentences of ant society. A forager discovering food lays a trail of scent, a path that others will follow, reinforcing the signal with each passage. If the food is plentiful, the trail grows stronger. If it dwindles, the trail fades, and the colony's attention shifts elsewhere. Danger, too, is marked with scent, alarm pheromones that summon reinforcements or trigger retreat. Each ant is both a sender and a receiver, a node in a vast, decentralized network. There is elegance in this simplicity. The rules are local, but the effects are global. The colony, in a sense, computes, a living algorithm solving the problems of foraging, nest building, defense, and reproduction without need for central oversight. In the language of computer science, this is called emergence. complex patterns arising from the interplay of simple agents following simple rules. The metaphor is irresistible. One can imagine the ant colony as a biological computer, each ant a processor, each pheromone a bit of data, the whole system iterating toward efficiency, resilience, and survival. It is perhaps no surprise that ants have haunted the dreams of scientists and storytellers alike. The image of the colony, a city of many, a mind of one, recurs in our literature and our nightmares. From the dystopian visions of H.G. Wells's Empire of the Ants to the philosophical musings of E.O. Wilson and Bert Hölderlin, ants have been both model and mirror, a warning of the dangers of conformity, an inspiration for the possibilities of cooperation. Yet, for all their alienness, ants are not so distant from us. Their societies, though built on different foundations, echo our own. They farm, they wage war, they care for their young, they build, they explore. Their cities pulse with energy and purpose, their highways teem with life. They have solved in their own way the riddle of collective action, the challenge of aligning the efforts of many to a common goal. And in studying them, we glimpse possibilities for ourselves. The algorithms that guide internet traffic, the protocols that coordinate fleets of autonomous robots, the principles that underlie swarm intelligence in computing, all draw inspiration from the humble ant. The notion that order can arise without rulers, that intelligence can emerge from the interactions of the many, is both a scientific revelation and a philosophical challenge. But ants are not mere metaphors. They are living beings, shaped by millions of years of evolution, honed by the pressures of survival. Their world is one of constant negotiation, perpetual adaptation. The supercolony is not a static utopia, but a process, a ceaseless balancing act, a perpetual improvisation. Boundaries shift, alliances form and dissolve, resources wax and wane. The great Argentine ant supercolony that spans southern Europe is, even now, locked in a slow-motion war with rivals, its borders advancing and retreating like the front lines of an eternal campaign. And still, on a quiet evening, you can kneel and watch as the lines of ants flow past, oblivious to your gaze, intent on their tasks. Each one a universe of sensation and instinct, each one a thread in a tapestry vast beyond comprehension. They do not know that they are part of something greater, nor do they need to. The colony knows, in its own way. The colony remembers, adapts, persists. As darkness deepens and the world cools, the rhythms of the colony shift, the tempo of activity changing with the fall of night. Somewhere underground, the queen continues her ancient labor, laying the eggs that will become the next generation of workers, soldiers, queens. Above her, the workers' close entrances, seal tunnels, and cluster together for warmth and safety. The supercolony breathes, contracts, and expands, dreaming its chemical dreams beneath the soil. Yet the mysteries of ant society run deeper still. If the colony is a mind, what are its thoughts? If the supercolony is an organism, where is its awareness? Can such a system truly be said to know or decide, or is it merely the sum of unthinking motions, a blind, beautiful pattern? The questions linger, unresolved, as the night thickens and the world of ants recedes once more into darkness. Beneath the quiet surface, the universe within the undergrowth continues its ancient work, a living riddle, a challenge to our understanding, a source of endless wonder. The ants march on, bearing their secrets, their silent intelligence, their uncanny unity. And somewhere in the cool soil, a new day waits to begin. What lies beneath the surface of this unity? How do the signals, the sense, the tiny decisions cohere into the grand design of the supercolony? To answer, we must descend further into the labyrinthine architecture of the nest, where the chemistry of communication weaves its intricate web, binding each ant to the fate of the whole. Beneath our feet, hidden from the daily rush and clangor of human ambition, lies a cosmos of miniature architects and mute engineers, the ant colonies, tireless and ancient. As the day's heat lingers in the crust of the earth, and dusk's cool fingers begin to soothe the grasses, the world below ground is alive with movement, purposeful, unceasing, and yet, to an untrained eye, strangely devoid of any visible order. If you were to peel back the layers of soil, as if opening the cover of an ancient text written in living script, you would find tunnels that spiral and intersect, chambers that expand and contract like the breathing lungs of a beast, and 1,000 small creatures darting in all directions. At first glance, it is tempting to name this ceaseless activity chaos, a frenzied dance with no conductor, no visible chain of command. Yet as we settle in to observe, to let the rhythm of their world become our own, the illusion of disorder slowly dissolves. Here is an anarchy that is not disorder, but a different kind of order, one that does not rely on top-down hierarchy, on a central authority issuing commands. Instead, the ant colony pulses with a decentralized intelligence, a distributed logic born from the sum total of thousands of tiny decisions, each guided by simple rules, chemical whispers, and the urgings of collective need. It is a lesson that hums quietly at the heart of the earth, one that flies in the face of the human tendency to impose hierarchy on every system we encounter. Our own civilizations, after all, are built upon pyramids of power, kings and presidents, generals and CEOs, directors and managers, all perched atop layers of subordinates. Even when we gaze into the animal kingdom, we search for analogues to our own structure, the alpha wolf, the queen bee, the dominant silverback. But the ants, in their billions, have written a different story, one that is both more ancient and, in its way, more radical. To understand this story, let us journey deeper beyond the surface tunnels and into the heart of the supercolony. Here the architecture itself begins to baffle the observer. Some ant colonies, such as those built by the Argentine ant, Linapithema humile, stretch for hundreds, even thousands, of kilometers. In southern Europe, a supercolony has been found that extends across 6 countries, containing billions, possibly trillions, of individuals. Where does this astonishing cohesion come from? How can such an immense society function when no single ant, nor even any small group, has a map of the whole or an understanding of its vastness? The answer lies in the very absence of a traditional hierarchy. In the classic sense, a hierarchy is a structure where individuals are ranked one above another according to status or authority. Power flows downward, from a leader to their subordinates, and from there to yet more subordinates. Orders are given, and those below obey. In this model, the smooth functioning of the whole depends on the clarity of the chain of command. But within the supercolony, there is no ant general issuing orders, no architect drawing blueprints for the nest, and not even, as it turns out, a queen who rules in the way a monarch does. The queen is merely an egg layer, vital, yes, but not a leader. She does not direct the workers, nor does she control the allocation of labor. She is in some respects as much a servant of the colony as any other ant. Instead, what arises is a phenomenon known as stigmergy, a form of indirect coordination through the environment. Each ant, equipped with a palette of simple behavioral rules and a sensitivity to chemical signals, responds to the traces left by others. A forager discovers a crumb of food, and as she returns to the nest, she lays down a trail of pheromones. Other ants, encountering this trail, are more likely to follow it, reinforcing the chemical path if they too find food at its end. The trail grows stronger, attracting still more workers until the food is exhausted, at which point the scent fades and the ants disperse. There is no overseer directing the foragers, no foreman assigning duties. The pattern emerges from the bottom up, a self-organizing system that is robust, flexible, and remarkably efficient. This principle extends to every aspect of ant society. When it comes time to expand the nest, workers begin to excavate, following gradients of humidity and temperature, guided by the presence of other ants and the accumulation of excavated soil. If danger threatens, a burst of alarm pheromones can recruit defenders from the farthest reaches of the colony. Each response is local, immediate, and yet, when aggregated across thousands or millions of individuals, the result is a coordinated whole. A living architecture that adapts to changing conditions, repairs itself, and grows without the need for central planning. It is not a stretch to call this anarchy, a society without rulers in the literal sense. But it is not the anarchy of collapse or confusion. Rather, it is the anarchy of complex systems, where order is not imposed from above, but emerges from the interplay of countless small actions and reactions. The supercolony is a paradox, at once chaotic and supremely organized. To grasp the depths of this paradox, we might turn to the world of literature, where science fiction authors have long toyed with the idea of societies without hierarchy. In Neal Stephenson's Snow Crash, for instance, we find a world fragmented into burbclaves and microstates, where authority is diffuse, borders are fluid, and the old certainties of nation and command are dissolved. The city in Snow Crash is not ruled by a single power, but by a shifting mesh of interests, corporations, and informal networks. It is, in many ways, a vision of human society as an ant nest, chaotic to the outsider, but internally governed by emergent rules and mutual adaptation. Stevenson's world is not utopian, nor is it a simple mirror of ant society. But it serves as a useful metaphor for the kind of order that can arise in the absence of rulers. The supercolony, like the burbclaves, is held together not by force or decree, but by a web of interactions, each one local and limited, but together forming a resilient and adaptive whole. If we return to the ants, we find their society is also marked by a kind of radical egalitarianism. Most workers are genetically similar, and differences in task are not fixed but fluid. An ant that spends the morning tending larvae may spend the afternoon foraging, and the evening excavating tunnels. The allocation of labor is driven not by orders, but by the needs of the colony, as sensed and responded to by individuals. This plasticity is profound. When the colony is young and small, nearly all ants nurse the brood. As it grows and new tasks emerge, individuals switch roles with remarkable flexibility, guided by the ever-shifting tapestry of chemical signals and tactile cues. The limits of our understanding become clear when we try to map these processes in detail. For all our advances in technology, for all the miniaturized cameras and genetic tools at our disposal, the inner life of the supercolony remains elusive. We can trace pheromone trails, analyze genetic lineages, and even tag individual ants with colored dots, but the emergent logic of the colony as a whole is difficult to grasp. Each ant's world is small, bounded by the range of her antennae and the faintest whiff of chemical news. Yet collectively they achieve feats of organization and adaptability that boggle the mind. Consider the phenomenon of ant wars, conflicts that arise between rival colonies, sometimes on a scale that rivals human battles in scope and savagery. In the Argentine ant supercolony, battles can rage along vast front lines, with thousands of ants meeting in thick, writhing knots. Yet even here, there is no commander, no grand strategist. The decision to attack or retreat is made by the collective through a process of local encounters and pheromonal feedback. If enough ants from one side are present and the chemical cues of the enemy are strong, the urge to fight grows. If losses mount or reinforcements fail to materialize, the tide turns and the ants fall back. It is a form of distributed computation, a rolling consensus built from the bottom up. This is not to say the ant supercolony is without its own forms of tension and contradiction. Anarchy does not mean harmony. Conflicts arise, mistakes are made, and sometimes the system falters. There are instances of colony collapse, where the delicate balance of signals breaks down and the once vibrant society disintegrates. Parasites and pathogens exploit the openness of the system, slipping past defenses that are strong but not infallible. And yet, over millions of years, the supercolony persists, its core logic proving astonishingly resilient. For the human observer, the temptation to project our own hierarchies onto the ants is strong. We seek the queen as ruler, the soldiers as generals, the workers as peasants. But the reality is far stranger, and in many ways more humbling. The ant colony is not a machine, with each part assigned a rigid function, nor is it a monarchy, with the queen as absolute sovereign. It is a fluid, adaptive network, governed by the principles of emergence and self-organization. To walk through a forest in summer, feeling the crunch of soil beneath your feet, and knowing that, somewhere below, a supercolony is weaving its unseen architecture, is to glimpse the limits of our own understanding. We are used to thinking in terms of plans, blueprints, and commands. The ants remind us that there are other ways to build a society, ways that are messier, more distributed, and perhaps, in their own way, more robust. As night creeps across the land and the last rays of sunlight slip through the trees, the ants are still moving, still building, still responding to the thousand small signals that shape their world. In the darkness beneath the earth, the supercolony dreams on, an endless experiment in collective intelligence and anarchic order. The lessons it offers are subtle, elusive, and still unfolding, a reminder that the world is full of architectures we have yet to decode, and that sometimes the deepest truths are hidden in the hum of a million tiny lives working together without a master. In the quiet, as you let your mind drift on the slow currents of these subterranean marvels, you may begin to sense the outlines of a deeper question, one that beckons us onward. If such anarchy can yield such order, what does it say about the possibilities of our own societies? What other hidden architectures lie waiting to be discovered, just beyond the reach of our current understanding? In the silence of the earth, the ants continue their work, and the mystery only deepens, inviting us to look again and to listen for the soft, persistent murmur of the unseen architects. In the gentle hush of the laboratory, where glass, steel, and silence conspire to create a cathedral for the curious, a different kind of story unfolds, a story not of heroics or legend, but of patience and precision. Here, the protagonists are not the ants themselves, but the hands and minds that seek to understand them. Tools, simple and sophisticated, become extensions of human wonder, weaving a bridge between our world and the intricate realities beneath a leaf or within a grain of sand. To study ants is to peer through a keyhole at the machinery of life itself, and the key, as it has always been, is observation. There is a certain poetry in the way a simple lens can transform a speck into a universe. The earliest myrmecologists, those who dedicated their lives to the study of ants, relied on little more than a keen eye and a magnifying glass. In the 18th and 19th centuries, as the Age of Enlightenment dawned, naturalists would kneel in meadows with their notebooks and small hand lenses, straining to follow the cryptic trails vanishing among grass blades. They were constrained by the limits of their optics, yet what they lacked in magnification they compensated for with patience. They drew sketches, annotated maps of nests, and described the choreography of worker and queen with the reverence of poets. And yet, it was not until the 20th century that a revolution began to stir. A young man named Edward Osborne Wilson, E.O. Wilson, as he would become known, found himself captivated by the elegant chaos of ant societies. Born in Alabama, Wilson's childhood was marked by a partial loss of vision in one eye, the result of a fishing accident. Deprived of depth perception, he adapted by turning his remaining keen eye to the ground, where the miniature dramas of the insect world played out in vivid detail. It was a twist of fate that nudged him so close to the earth, so close to the ants. Wilson became the great chronicler of the ant world, a pioneer whose tools ranged from humble collecting vials to elaborate field experiments. In the forests of New England and the tropics of Suriname, he would kneel for hours, peering into the heart of a colony, marking the comings and goings of workers with tiny dabs of paint. The paint was more than an identifier. It was a passport, granting each ant an identity that could be followed through the tangled labyrinth of the colony's days. With patience bordering on devotion, Wilson mapped the hidden highways of ant communication and division of labor. He would scoop a handful of soil and nest into a glass terrarium, creating a living diorama in his laboratory. There, under the steady glow of a lamp, he could observe the colony's rhythms, the way workers formed living bridges, the tidiness of their cemeteries, the ceaseless tending of larvae. Wilson's notebooks filled with diagrams and observations, each entry a step closer to deciphering the code of ant society. But even the most attentive human eye falters before the sheer scale of an ant colony's complexity. The number of individuals, the maze of tunnels, the ephemeral signals exchanged in the darkness, these mysteries demanded new tools. It was in the spirit of ingenuity that myrmecologists began to invent. The ant farm, or formicarium, became an emblem of both education and research. A living colony, sandwiched between panes of glass, revealed the architecture of tunnels and chambers as if the earth itself had become transparent. Children and scientists alike watched, transfixed, as ants excavated galleries, tended their brood, and staged territorial skirmishes. The formicarium was a controlled universe, a microcosm where every movement could be scrutinized and measured. Yet the formicarium also posed a paradox. It made visible the invisible, but at the price of distortion. The artificial confines, the absence of the wild's unpredictability, meant that the story it told was only a chapter, not the whole epic. To truly understand ants, researchers had to venture into their world. Fieldwork became a ritual of patience and ingenuity. Myrmecologists constructed elaborate pitfall traps, simple cups sunk flush with the earth, baited with morsels of honey or tuna. Ants, ever the opportunists, would tumble in, and from the species court, scientists could map the invisible highways of ant populations across a landscape. Foraging trails were dusted with fluorescent powders. Under ultraviolet light, the powder glowed, tracing the secret byways of the colony, the branching networks that mirrored the blood vessels and neural circuits in our own bodies. The language of ants, written in pheromones and footfalls, demanded even subtler instruments. Gas chromatographs, delicate machines that separated and identified the chemical signatures of ant communication, revealed the invisible signals exchanged among nestmates. With these tools, researchers began to decode the chemical lexicon ants used to summon help, declare war, or announce the presence of food. Each new peak and trough on the chromatograph's printout was a word, a phrase, sometimes a whole sentence in the language of the colony. Sometimes the act of observation itself became an experiment. In one of the more whimsical but illuminating studies, E.O., Wilson and his colleagues would mark individual ants in a colony, then remove the queen and carefully watch the response. Would the workers panic? Would they search for her? The answer, it turned out, was yes, but not because they recognized her by sight. Instead, the queen's absence left a silence in the chemical chorus, a missing pheromonal signature that unsettled the workers until she was restored or replaced. Other experiments played with the boundaries of ant cognition. Could ants count? Did they remember landmarks? In the deserts of Tunisia, researchers glued tiny stilts to the legs of Sahara desert ants, artificially lengthening their stride. When released, the ants overshot their nest by exactly the distance corresponding to their new, longer steps. The experiment was a small marvel, proof that ants measured distance not by memory or vision, but by a kind of internal pedometer, counting their footsteps like clockwork. As the 21st century dawned, the tools of myrmecology leapt forward in tandem with technology. The digital revolution, with its sensors and algorithms, invited a new intimacy with ant lives. High-speed cameras, capable of capturing the flutter of a gnat's wing in slow motion, now recorded the balletic precision of ant foraging and combat. Infrared cameras peered into the darkness of underground nests, revealing the midnight traffic of workers and the pulse of the colony. Then came a moment of inspiration from an unlikely source. In the film Minority Report, detectives sift through a deluge of visual data, their hands conjuring images in mid-air. Computer scientists and myrmecologists saw in this a blueprint for tracking the chaos of an ant colony. What if, they wondered, every ant could be followed, every movement recorded and analyzed, not by a lone observer with a notebook, but by an algorithm, tireless and unblinking? Researchers developed sophisticated tracking systems, using video footage and machine learning to assign a digital identity to each ant. In one pioneering laboratory, a colony of Argentine ants was introduced to a transparent arena. Overhead, an array of cameras watched, while software traced the path of every individual in real time, constructing a living map of the colony's foraging, fighting, and nest maintenance. The resulting data, streams of coordinates and timestamps, could be sifted by algorithms for patterns invisible to the human eye. These digital ant farms revealed emergent behaviors, traffic jams at narrow passages, the formation of living bridges, the spontaneous synchronization of activity cycles. Researchers could simulate disturbances, block a trail, remove food, or introduce an invader, then watch as the algorithms documented the ripples of response through the colony. The computer, with its tireless memory, became a new kind of observer, capable not just of watching, but of noticing. Yet, for all its power, technology did not diminish the need for human curiosity. The best experiments were those born not of necessity, but of wonder. In a quiet corner of a laboratory, a researcher might still pause to watch an ant struggle with a crumb twice its size, marveling at the stubborn ingenuity that centuries of evolution had wrought. New tools brought new questions. With genetic sequencing, scientists could peer into the blueprint of ant bodies, unraveling the genes that gave rise to queens and workers, soldiers and scouts. They discovered that the castes of an ant colony were not merely roles assigned by fate, but expressions of molecular switches, genes turned on or off by the whispers of pheromones and the touch of a nestmate. By silencing a gene or activating another, researchers could coax larvae into becoming queens or workers, glimpsing the levers that shaped the society of the colony. In the wild, GPS collars, miniature marvels of engineering, were fitted to leaf-cutter ants, allowing scientists to track their epic foraging journeys across the rainforest floor. The data painted a living portrait of resource flow, the way a single colony could reshape an entire patch of forest through its relentless harvesting of leaves. Drones hovered above savannas and jungles, mapping the distribution of ant nests, tracing the invisible footprints of colonies across the land. At the interface of biology and mathematics, computer models blossomed. Researchers fed their hard-won data into simulations, asking not just how ants behaved, but why. What rules gave rise to the collective intelligence of the swarm? How did simple interactions between neighbors produce the ordered chaos of a colony at work? The answers, encoded in lines of code and equations, revealed a universe where order emerged from the dance of many, each ant following a handful of simple rules, yet together achieving feats no individual could imagine. some of the most elegant experiments return to the basics: a question, a handful of ants, and a controlled setting. In the laboratory, researchers constructed mazes of increasing complexity, challenging ants to find food or escape. By varying the scent of the trails or the pattern of the maze, they tested the limits of memory and decision-making. Ants, it turned out, could learn from experience, adjust their strategies, and even imitate the successful tactics of their peers. In other studies, scientists introduced glass barriers or painted false trails, probing the ants' reliance on vision, scent, and even polarized light. In the sun-baked deserts, some species were found to navigate by the position of the sun, using the polarization pattern in the sky as a compass. Tiny mirrors and filters, deftly wielded in field experiments, revealed the secret navigational aids ants carried within their bodies, a marvel of natural engineering honed over millions of years. Through it all, the spirit of myrmecology remained one of humility and wonder. Each new tool, each clever experiment, was less a conquest than a conversation, a way of asking the ants to reveal a little more of their world. The laboratory and the field became spaces of listening, where the scientist's role was not to impose order, but to attend to the order already present, hidden just beneath the surface. And so, the study of ants became a mirror for our own desire to understand the living world. From hand lenses to algorithms, from paintbrushes to gene sequences, each instrument was a testament to the power of curiosity. The ants themselves, tireless and enigmatic, kept their secrets, offering glimpses to those willing to watch, to wait, and to wonder. Somewhere even now, a light burns in a laboratory. A myrmecologist, perhaps inspired by Wilson's legacy or by the glimmer of new technology, leans close to a glass-walled nest, eyes bright with questions. In the hush, the colony stirs. Workers file along their trails, larvae are tended, food is gathered, and the rhythm of ant life continues, indifferent to observation, yet somehow all the more wondrous for it. Beyond the walls of the laboratory, the tools of the tiny titans continue to evolve. What new marvels might be revealed as technology sharpens its gaze? What secrets lie hidden in the darkness of the nest, waiting for the patient hand and the curious mind to bring them to light? Even as the night deepens, the story of ant observation remains unfinished, a quiet invitation to peer closer, to ask again, and to listen for the answers written in the footsteps of the colony. Across the long hush of the evening, as the world outside your window softens and the day's last light slips away, let us drift together into that liminal space where science and philosophy intertwine. The story of ant supercolonies, those teeming living tapestries woven by countless tiny beings, brings us now to a realm of reflection, a garden of questions, old and new. Here, the lines between ant and human, between instinct and intention, become a little less certain. It is a quiet place, suited for the slow unraveling of thoughts. Let us linger first with the simple fact that a supercolony, a city of ants so vast it spills over continents, its individuals numbering in the billions, exists at all. We might ask, how is it that such a society functions without a central mind, without a ruler or a blueprint? How do they persist, adapt and thrive when each ant is so limited, so oblivious to the grand scheme? In the warm earth beneath our feet, inside hollow logs and deep within cracks in the pavement, the supercolony pulses. There is no throne, no council, no voice that commands. Each ant, born to her purpose, responds to signals as immediate and fleeting as the scent of a chemical trail. And yet, out of these local, simple acts arises a living order that stretches across time and space. It is as if the colony itself is an emergent mind, one that belongs to no single ant, but to all of them together. The science of emergence gives us some language for this, systems in which the whole is more than the sum of its parts, where local interactions lead to global patterns. In ants, this means that the ceaseless foraging, the tending of larvae, the defense of borders, the sharing of food, each act, though blind to the greater plan, creates a society that endures. Here, the philosophical mind is drawn irresistibly to analogy. We too are participants in vast, complex societies. Our cities are tapestries of human striving, each of us following our own urgencies and desires, yet building together something none of us could build alone. But unlike ants, we have leaders, presidents, prime ministers, monarchs. We have parliaments and constitutions, courts and codes. We have stories of great individuals who shape the world. The leaderless order of the ant supercolony seems, by comparison, both alien and alluring. What would it mean, we may ask, for humanity to embrace a leaderless society? Is such a thing possible or even desirable? Aldous Huxley, in his novel Island, imagined a human community built more on consensus than hierarchy. His parlour is a place where decisions ripple through the population by discussion and mutual agreement, where the machinery of state is minimal and coercion is rare. The Colonies, like ants, trust in the wisdom of the group, the accumulated insight of many small minds. But ants, of course, do not debate. They do not reason, nor do they resent. Their order is born of evolutionary time, etched into their genes. Each ant's role is a product of chemical signals and genetic destiny. The absence of leaders is not a choice, but the outcome of countless generations of natural selection. For humans, the question is more fraught. We are creatures of imagination, capable of seeing ourselves as actors upon the stage of history, of yearning for meaning, of rebelling against our roles. Yet the pull of the ants' collective wisdom remains. Scientists have marveled at the resilience of supercolonies. When a section of the colony is destroyed, the rest persists. When resources shift, the colony adapts. No single death, no sudden loss can bring the whole to ruin. There is a distributed intelligence at work, an order that arises because no part is indispensable. Human societies, with their top-heavy hierarchies, can be brittle by comparison. When a leader fails or a system breaks, the whole may teeter on collapse. In the soft light of this insight, we might wonder, could we learn from the ants? Could we design our societies to be less dependent on the few, more resilient to shock? Scientists and philosophers have long toyed with this idea. In the 21st century, the language of networks, of decentralized systems, has crept into everything from economics to computing to politics. The Internet, after all, is a kind of supercolony, a vast web of connections, with no single node in command, yet capable of astonishing feats. But there are limits. Humans are not ants. Our needs are more complex, our desires more varied. We tell stories, wage wars, fall in love, grieve and hope. We are burdened with memory, with the longing for justice, with the ache for recognition. The ant society, for all its elegance, is indifferent to the individual. The colony must survive, even if its members are spent and discarded. This too is a lesson, one that chills as much as it inspires. In Huxley's Island, the Colonies strive to balance the needs of the many with the dignity of the few. Their society is not ant-like in its suppression of the individual. Rather, it seeks harmony between self and group. The Colonies believe in mindfulness, in attention to the moment, in kindness and mutual aid. Their leaderlessness is not the product of instinct, but of choice, a fragile, deliberate construction maintained by effort and care. So we find ourselves at the edge of sleep, pondering the paradox. The ant supercolony is a marvel of natural engineering, a testament to what can emerge from simplicity and cooperation. It is a society without leaders, without ego, without the drama of ambition or the tragedy of loss. Yet it is also a society without art, without love, without the wild, unpredictable joys and sorrows that define the human condition. To reflect on supercolonies is to reflect on the meaning of our own social bonds. The philosopher might see in the ants a vision of perfect harmony, a world where conflict dissolves into cooperation, where every member knows her place. The skeptic, meanwhile, might see only the tyranny of the collective, the unbearable anonymity of life without individuality. And yet, in the slow unfolding of scientific understanding, we begin to see that the story is subtler still. The ants are not all alike, nor are their roles fixed forever. In many species, workers can shift tasks to meet the colony's needs. When disaster strikes, new patterns emerge. There is flexibility, even creativity, in the supercolony's response to the world. This, perhaps, is the deepest lesson, that complexity can arise from simplicity, that order can emerge without command. In the language of science, this is the principle of self-organization, a principle that shapes not only ant colonies, but the flocking of birds, the swirling of galaxies, the patterns of weather, and the branching of rivers. It is a law written into the fabric of reality, a quiet assurance that order and beauty can arise unbidden from the dance of countless small parts. In that light, even the most human of questions, how shall we live together, how shall we govern ourselves, takes on a new hue. The ant supercolony does not offer answers, but it does suggest possibilities. What if we trusted more in the wisdom of the crowd, in the power of distributed decision-making? What if we built systems that learned and adapted, that did not depend on the heroism or failure of a few? What if, like the ants, we found ways to thrive together, not by suppressing the self, but by weaving our individuality into a stronger collective? Of course, there is no easy road from ant-hill to human city. The distances are immense, the challenges profound, and yet on quiet nights it is good to wonder. Huxley's parlor, the dream of a society guided by mindfulness and mutual aid, remains just that, a dream. But dreams, like the patterns in an ant's trail, have the power to shape reality if only we attend to them. Somewhere, deep in the soil, a supercolony stirs. Its members go about their tasks, untroubled by philosophy, indifferent to mystery. But for us, the watchers, there is both awe and humility in the spectacle. We see ourselves reflected, distorted but familiar, in their ordered chaos. We see the promise of cooperation, the danger of conformity, the endless tension between self and whole. Perhaps, as the night grows deeper, it is enough to linger with the questions, to marvel at the mystery of the ant supercolony, and to carry its lessons, half understood, half imagined, into our own uncertain future. There is much we do not know. The world is vast, and the ways of life are stranger and more various than we can guess. As you settle into silence, let your mind wander through the corridors of possibility, leaderless societies, emergent minds, the delicate balance of order and freedom. The ants remind us that life, for all its complexity, is sometimes shaped by the simplest of rules. They remind us, too, that we are not alone in our striving, that we are all participants in something larger than ourselves. And so, in the gentle hush of the hour, let the questions remain unanswered. Let the mystery of the ants linger, shimmering at the edge of understanding, as you drift toward dreams where the boundaries between ant and man, between science and soul, dissolve into the quiet hum of possibility. And so, our journey through the silent symphony of ants building their vast supercolonies drifts to a close, like a comet tail fading gently into the hush of space. May you carry this quiet wonder in your thoughts as you drift toward peaceful dreams, and return soon for more Dreamtime tales that unravel the mysteries of our world.